Welcome to the LRC, where you can impress everyone with how super duper smart you are. Let's test your math skills. What is 1 plus 2 times 2? The correct answer is 5. Did you get 6? That's because you did the operations in the wrong order. Before we can discuss what the right order is, let's first explain what an operation is in the first place. Essentially, operations are the symbols in equations that affect numbers, but they aren't numbers themselves. The plus sign, for example, is the operation that represents two numbers adding together. The minus sign is for subtraction, and the equal symbol is not an operation because it doesn't affect the numbers themselves. It just tells you that this thing is equal to that thing. Now that we know what an operation is, we can discuss when we do them in the equation. There's this acronym we use called GEMDAS to remember the order of operations. That's grouping, exponent, multiplication, division, addition, and subtraction. You might also hear PEMDAS, which replaces grouping with parentheses. But the reason we're using GEMDAS for this is because we have more grouping symbols than just the parentheses. These all can be used to represent groups, and sometimes we need more than one for when we have a lot of groups. Any questions? No? Really? Okay. Well, I have a question. Isn't multiplication just grouping as well? That's what we said last video, right? So why is multiplication a separate operation in the acronym? You'd be right to say they're the same, but here's the key difference. The grouping we look at in GEMDAS isn't the grouping symbols themselves, but what's in them. The actual group. Look at this example. We have the group 8 plus 3, but we also have the multiplication, 4 times 2. Why do we have to do 8 plus 3 first here? Well, pretty simply, there's just nothing to do with the other group. It's just a 2. There's no other operations within the 2 itself. Its relationship with 4 is outside of the parenthesis, so we save that for later. Alright, with this in mind, let's go back to the problem at the start of the video. 1 plus 2 times 2. First, let's check for parentheses. Can't find any here. So, what about multiplication and division? Yeah, we have 2 times 2, so you do that. Now we have 1 plus 4. You should know this, right? 1 plus 4 is 5. That's our answer. Alright, here's another example. 6 plus 7, 7 minus 2, plus 7 minus 5. Pause the video here and think for a little bit. First, you do the parentheses. 6 plus 7 is equal to 13, and 7 minus 2 is equal to 5. Now we have 13 times 5 plus 7 minus 5. Now, we use the multiplication. 13 times 5 is equal to 65. 65 plus 7 is 72. Then you subtract the 5 to get 67. Alright, let's have one last problem. If you watched our last video, you saw how we could isolate variables by getting rid of the coefficient and the constant. So, applying GEMDAS, find x if 5x plus 13 divided by 4 is equal to 10. Okay, here's the tricky thing with isolating x. You need to do the operations in reverse order, because you need to find what x was before you added all the extra steps. So if grouping is our first step, and division is our second step, to get rid of the steps, we have to get rid of step 2 first before we get rid of step 1. So, we multiply both sides by 4. Now we have 5x plus 13 is equal to 40. We still follow reverse GEMDAS here, so before getting rid of the coefficient, which is our multiplication, we get rid of the constant, which is addition. Now we have 5x is equal to 27. If we divide 5 by both sides, we get x is equal to 27 over 5. It might look a little weird, but 27 over 5 is already the smallest that number can go, so we don't actually need to change it to be anything else. Even decimals are just the same thing, just phrased a little differently, so there's no point in necessarily changing it to a decimal, though you're welcome to do so anyway. Before you go, here are a few problems you can use to practice your GEMDAS even more. Since you've done the previous example, These should come easy. Like last time, the answers will be in the description. See you again soon.